Okay, so good morning again, everyone. Today it's my pleasure to introduce Dr. Madalyn Blonde. She will be talking about oil and gas wastewaters, commodities, and other constituents affecting reuse. Before she starts, I would like to introduce her. Dr. Madalyn Blonde is the co-lead of the Oil and Gas Waters Project funded by the Energy Resource Program at USGS and is a supervisory research geologist at the Geology, Energy and Mineral Science Center in Reston, Virginia. Her current research focuses on the geochemistry of oil and gas wastewaters and geologic carbon dioxide storage through mineralization. Dr. Madalyn has obtained her BA from the Sonoma College Geology Department in 2003 and her PhD from the Yale University Department of Geology and Geophysics in 2008. She also did her postdoctoral at University of Maryland before joining USGS in 2010. So thank you, Dr. Madalyn, for agreeing to present in this seminar series, and we are looking forward for your presentation. The stage is all yours.
All right, thank you so much. And thank you to everyone for having me today. I've been very excited to present this and talk to all of you. I know that Texas BEG, a number of you down there have been doing this type of work for quite a while. So I'm excited to show you some of the things we've been working on, some of the things we're thinking about, some of the field work we've been doing, and try to give a holistic look at some of the issues related to oil and gas wastewaters. I just want to acknowledge some of my colleagues. We're working on a number of different either papers, studies, or the produced waters database together, and I'm acknowledging some of them here as my co-authors. Okay, so what are oil and gas wastewaters? They are the largest waste product of oil and gas production. Anywhere that anywhere that oil and gas come to the surface, water is always a byproduct. And it can be quite voluminous. There has been work comparing it to other industries. It's not an exceedingly large amount of water, but when we're looking at, particularly in drought-prone regions or areas of high water stress, there are reasons to look at potential reuse of this water. In particular, this water can be extremely saline, so more than 10 times saltier than the ocean. This is not stuff that you can just put on the surface. It'll kill crops and whatnot. It also is difficult to process some of the hypersaline brines in, say, water treatment facilities. It'll corrode pipes. It'll have all kinds of other effects. It'll cause scaling. But once you start looking at this really salty water, one of the other questions is what can you potentially pull out of it to offset costs? And there has been, a big push lately looking at commodities. There are some, I mentioned, actually, no, I did take it out here. There are things like rare earth elements people are interested in. Those tend to be particularly low in produced waters. But there are things that may be quite high in basically that you have economic concentrations, particularly of things like lithium. And so I'm going to focus on that. And then one of the things that we have to think about is, okay, if we are reusing this water in some way, the water is so chemically variable that depending on how we use it, how we want to use it, that can really determine how much water is available either for reuse or commodity recovery. And so that's a really important point. I'll probably repeat a couple of times as we move forward here. So I'm talking about three main things today. And so as I kind of just mentioned, it's one thing to say, okay, how much water is coming out of the ground along with oil and gas? But because it's so chemically variable, depending on how we want to use it, we really have to understand the chemistry. And so my colleagues and I have come up with some techniques using a lot of existing data for both the volume information and some of the chemistry to basically come up with base maps that you could feed into water availability studies. And so you're able to actually make an estimate of, okay, I want water below this salinity, how much is actually coming out of the ground on a yearly basis. So this is the kind of stuff that we're targeting. The other thing I'm going to discuss is just generally looking at commodities in produced waters. So again, mostly focusing on lithium here, but I'll briefly touch on a couple of other things as well. And then lastly, this is something that comes up a lot. A lot of people are particularly excited about this. What can we get out of this water? But there are a couple of things that need to be taken into account when you're thinking about costs or potentially impacts. And I'll just jump to that here, but those things are generally going to be radium, so naturally occurring radioactive materials, and potentially things like high H2S. And we just had to do some very fun high H2S sampling following a bunch of OSHA rules, and I'll show some images of that as well. Okay, so first I want to talk about quantifying available produced water. And so this is the issue of, again, there are a lot of existing models for water availability, water use, looking at the food, energy, water nexus. The USGS is now doing integrated water assessments, and none of these things generally include produced water. It is comparable in volume to a number of the different sources. It probably should be looked at. And the reason, again, it's difficult to do this is because it's so chemically variable. People generally are like, well, we're just not going to touch that for now, or assume it's entirely unusable. And so at the USGS, we also do a lot of assessments, including water assessments. This is like co-lead of the project, Seth Haynes, who had done a produced water assessment. So looking at the amount used, the amount produced. And so we've done a lot of work to try to tie these things together in order to say, okay, how much can we potentially use? Also wanted to mention, this is relevant to some of Bridget's work here. So again, this is, keep driving home this point, depending how you want to reuse the water or what you might want to pull out of it, you really have to understand what the composition is and how that affects the actual volumes coming out. And so first, I'm just going to talk briefly about the chemistry, what the typical compositions are, and then also just a bit about what sort of volume information that we have to combine it with. So this is the older version of the current version of the produced waters database. The new version, I realize I'm saying this regularly, but it's actually almost in review right now, and some of the plots I'm going to show you later are from this compiled version of the new database. But basically, we have, in many cases, hypersaline brines. So you'll see that black line on the legend there is the seawater composition. So that's already way too salty to drink. And even, you can obviously desalinate seawater. It's costly, but people do it. But so we're talking about orders of magnitude potentially above that. And including a number of organic compounds, including things like, again, radium. And so, it's definitely something that needs to be characterized. And so you can see all this water data is basically overlapping where we see oil and gas production across the US. Just a general concept. So these are usually sodium chloride brines. So you can see the gray and the blue, this concentration of sodium and chloride. The next dominant ion is generally calcium, and that can range through different basins. So I'm basically looking at some of the different basins and looking at the proportion of different major cations and anions. And then as we move through this, we start looking at minor and trace. There are certain basins, I think I highlighted, bromide, for example, can be quite high, particularly in places like the Arkla Basin and the Gulf. Most of that's coming from Smackover and the Cotton Valley as well. So you can get highly elevated bromide. Sulfate is generally quite low, and it's only fairly high in regions where there's a lot of freshwater recharge, which brings in sulfate. But so all this to say, there's a general idea of produced waters being sodium chloride brines or sodium calcium chloride brines, and then with a range of some minor and trace components. And so these are some of the trace components. Again, the red horizontal line is the, oops, sorry. That's the EPA maximum contaminant level, which, you know, is a something that's more compared for drinking water, so that shouldn't, you know, be seen as, oh, everything's above it and that means it's necessarily bad. But just to show you certain things, you can see on the far right, radium again can be quite high. Things like barium are quite elevated in produced waters, and even looking at you know, some potential critical commodities, and I'll talk more about that a little bit later. Okay, and so now just looking at the volume information. So again, in this first section, I'm talking about how do we actually come up with usable base maps that we can feed into water availability models using produced waters. And so this is IHS data. So this is production data. So all of the information you can get from IHS, you know, whether or not you're looking at TOPS or oil and gas production, you know, you also can get water there as well. And so we compile, this is just Ohio, and I'll show you some national scale or more focused basin maps in a minute. But this is again driving home this point that, okay, when you're getting, so you're basically seeing the Utica production here. So there's, you know, basically all conventional production going on in Ohio, and then you suddenly see this really quick shot in the toward the end of this image of the skiff, where you see a lot of production, and so, you know, both oil, gas, and then brine as well. Okay, and so here's what we put together. And so now I'm looking at the Permian Basin here. So this is a similar plot going back a little bit earlier. And so showing, I don't believe, actually this is a cumulative plot. So this is a cumulative water volume by year. So each year you can see it's adding a little bit more. And so we basically summed it to the county level. The main issue is, okay, you have two very different data sets. How do you take something that, you know, you have well information? So from IHS, we actually do get water volume per well monthly that we then sum to yearly. And then, but the problem is that the produced waters database and then other papers may have, you know, one analysis taken in 1983. And so, you know, do we assume it's the same over time? Are we looking at different formations? And so, you know, when we're actually talking about reuse of water, I think the important thing is not necessarily, oh, what formation is it coming out of? We're not trying to necessarily do a study on the characterization of the smackover or something for this particular purpose. It's more, you know, what's the bulk composition that's coming out of the ground? And so what we did was basically where we had data in a given county, we would average that chemical data to that county, and then we would compare it to the summed volume coming out of each county. And so you can see at this top right image is just a salinity map. So that's that average salinity by county in the Permian Basin. The second image is the cumulative volume of water that's come out. So and I forgot what my initial cutoff was. It's whatever the first year was, sometime in the early 80s or late 70s, for coming up with production. And then we basically just did a simple calculation to say, okay, if we have some kind of cutoff, say I want to know how much water is available that's less than 300,000 milligrams per liter, total dissolved solids. I don't know if I said this specifically, but I'll use total dissolved solids and salinity interchangeably here. And so say, for example, there's a, you know, desalination, and it can be used up to that point, and that's pretty saline, frankly. But then we can determine the amount of water per county, either yearly or, you know, even monthly, or sum to the basin, the amount of water that's coming out that's below that salinity, the average salinity per county. This is what we're calling valinity here. And so here's just another example in the Appalachian Basin where I do a lot more work. I'm trying to include some more Texas and Gulf and Arcala Basin stuff in here as well, but most of my work has been in the Appalachians. And so this is basically the same thing again. So you can say, okay, how much water less than a certain salinity? But say we're more interested in other things. So say, for example, you know, in the Appalachian Basin, it's known that a lot of the water has high concentrations of radium, which can be an environmental and human health hazard. And so say also too, you know, something at 300,000 is very salty. Is that realistic for what sort of water treatment process we might want to look at? And so the image on the left is basically saying, okay, let's not have a 300,000 milligrams per liter salinity cutoff. Let's bump it down to 150. How much usable water are we actually looking at? And so you can see you've kind of gone down to you know, certain counties, and frankly, this is, you know, well, compare it to the last one here. Yeah, so, you know, you start minimizing where you can potentially get water. And then if you want to say, okay, well, I only want to look at places where I know the water is less than, in this case, 100 picocuries per liter, radium 226, and these are all kind of arbitrary just to show kind of how this would work. Then you actually don't have a lot of usable water, right? You know, which means, okay, if you wanted to pre-treat that water first to pull out radium, and there are ways of doing this with barite precipitation, which is, you know, a whole different thing, and actually a plug for a postdoc that's been working with me, Bonnie McDevitt, who's been working on all things radium related to produced waters. And is investigating these sorts of things, but now you have less of a usable volume. Okay, and I will go back to this in this next section here, because we also can show potentially like mass of commodities of different like basically the masses of different commodities coming out of produced water using the same data set. Okay. So commodities and produced waters. I alluded to this in the beginning here. There's been a lot of push recently of, you know, what can we get out of this stuff? Is it gonna you know, reduce costs of wastewater injection or treating the water? You know, if we, you know, we're looking at critical minerals, and there are a lot of them that are in produced waters. But the question really is, you know, are they at economic concentrations? Is it worth it? You know, and so one of the things I kind of keep going back to is that, you know, yes, you can get lithium from some pegmatites or from, you know, certain evaporites and salt beds and whatnot. But if we're not, you know, if it's not in a region where there's existing infrastructure, or there's not local buy-in of, you know, setting up a big mine. I think one of the most important things with oil and gas wastewaters is that the infrastructure is there. It's already existing. You know, there's also this existing waste stream that's constant. You know, even if we're moving toward an energy transition, we're still looking at quite a bit of oil and gas production. And this is just EIA data. I mean, I downloaded it again the other day, so it's pretty current. And so we basically see, particularly from, you know, these tight oil and shale gas reservoirs, we're going to have a lot of production. We're going to have a lot of wastewater, and some of it does have high concentrations of potential commodities. And I know, you know, even I was at a meeting 2 weeks ago in the Appalachian Basin with some operators, and you know, it's a big push right now, as I'm sure it is down where you are as well. Okay, so this is some of the newer data. As I mentioned, it's not fully complete, and some of it you can't really see in the maps. We're still working on some of the location information. But so lithium, I wanted to focus on lithium here for a couple of reasons. You know, some of the main things that I think are pretty important, just based on the concentrations that I'm seeing in the data. You know, Bromide is quite high. I'm gonna show an image of that in a couple of slides. Lithium is really quite high, and then near-ish all of you know, obviously there's the Smackover, yeah, mostly concentrated in southern Arkansas, and that's sort of been the target, you know, at least according to the conversations I've had with people, you know, Smackover brines, they're extremely high bromide. There's already industry that's taking the effluent from the bromide production plants and trying to pull lithium out of it. And so it seems to be the first place where people are really going to try to do this. But one of the things I wanted to mention, you know, up until fairly recently, I was even thinking, okay, you kind of have the Smackover, and that's sort of your tier 1 potential lithium source. And then there are sort of these secondary reservoirs, particularly in the Appalachians and the Williston. But the more I look into it, there are some super high lithium concentrations in Arkansas, but frankly, there are also a lot of really high lithium concentrations in the Williston and in the Appalachians. Particularly from conventional reservoirs. So a lot of these older oil reservoirs, and I'm going to go into a little more detail in the Appalachians and the Williston as well in the next couple slides. But just to show here, this is kind of the spread of existing lithium data, minus a couple of the new data sets where we need to come up with centroids for some of the data points where there aren't actual lat longs to put on here. But you can see that the highest stuff is going to be, as I mentioned, you can see those blue dots in southern Arkansas. That's the Smackover. You can see that whole trend. The different colors are just basin names here. But most of that is all the Smackover that you can see kind of in that trend going from Texas down to Florida. And there are other regions, again, in the Appalachians, in the Williston, where they are quite high. Okay, so I'm just going to have two slides, one that's focusing on the Appalachians and one that's focusing on the Williston here. And so now the color coding is by the formation name. And so let's see, is that data on there? One of the things that's pretty interesting. So the Marcellus is in the light green, and the Utica is in kind of a darker purple. And so both of those are definitely elevated. So you know, this is all of the continuous or the unconventional production that's going on. It's mostly focused on the Marcellus and the Utica. But there really is quite a bit of conventional wells that have high concentrations as well. There's actually some more New York data that didn't make it onto this map here. But there are quite a few reservoirs with quite high lithium from conventional production. So again, when we think about energy transition, you know, even places where there's not shale gas production going on in the Appalachian, there is existing infrastructure. There are wells from older conventional wells that does have high lithium brines. So that's something to consider here. All right, and here's the Williston, and this one is pretty interesting as well, frankly. So, you know, if you actually are looking at the Bakken, there are a couple little pink points down toward the bottom. It's not particularly elevated, and I should say I made a cutoff. I think both the last one and this one were, this one's a 40 milligram per liter cutoff. The one before it was 10, just to show, you know, there's quite a bit of data that's kind of lower. And this one's looking at 80. So, you know, even the minimum is higher in this one. And so the Bakken, the data that we have is actually pretty low. So the Bakken and the Three Forks. So if we're looking at like the actual tight oil reservoirs here, do I have any Three Forks on here? I don't think once I got to the 80 milligram per liter cutoff. But if you start looking at some of the older conventional reservoirs, like the Duperow, the Charles, the Madison, so these are ordered by the maximum lithium concentration here. So the Duperow has the highest max. We actually see quite high lithium here as well. Okay, and so this is what I was referring to. I was going to go back to this. So if we're thinking about commodities in produced waters, so we took those kind of salinity map type things that we had made and said, okay, instead of coming up with yearly production or cumulative production, I want to take the average lithium concentration in a given county and then sum up the amount of water that's come out in the 20 years between 2000 and 2020, and then determine the mass of lithium that's been produced. And so that's what this map is. And so you can see these like kind of hot pink little areas in southern Arkansas. That's the Smackover. And so again, you have this like super high region here, and then when you actually average stuff out, it's quite a bit lower. But I honestly feel like if you're looking well by well, there actually are places with comparable lithium in parts of the U.S. other than the Smackover in southern Arkansas. And then the same for bromide. I mentioned that in southern Arkansas, there's a company, Lanxess, that's producing bromide, and now there's a new company, Standard Lithium, that is taking the effluent from that and trying to produce lithium out of it. And so bromide is frankly another thing. It's still on the critical minerals list, at least for the USGS. This small area in southern Arkansas produces something like, I think I have that on the next slide, so I'll wait for that. But just to say that when we're thinking about how we can actually make useful products or useful information that can feed into other types of questions of how we can reuse this water and what we can pull out of it, this is another example. Okay, so I did want to talk a bit. I think I just have like one or two slides of this. I have some colleagues at the Lower Mississippi Gulf Water Science Center who are working with the Arkansas Survey, and so they are working on a basically making maps of lithium in southern Arkansas and the Smackover in general. And they had contacted us a while back about getting some help with sampling and interpretation, and we had. So there is a lot of existing data out there, but this is filling in some of those gaps and looking at other reservoirs as well. And we had the first field work I had been able to do in years between the pandemic and having a 1.5-year-old. So I was very excited, and it was extremely wet the entire week. And I brought some new people out, and we had these ridiculous 12-hour days, and I probably should have done that to the team, but we got a really great data set. So again, the goal here, and this is being led out of by my colleague Kathy Knierim, from their perspective, is characterizing the resources, and then we are doing a couple of things. So we're helping understand the origin of the high lithium brine. So there's been a lot of work on bromide in this region, and so I'm not going to get too into this. We just got data back last week, and I was tempted to throw it in here because there's some really cool stuff in there, and I think some really interesting and I think novel interpretations. But I'm gonna hold off on that until we're able to get the full data set and really put everything together here. We're also doing a number of things, and this I'll jump to the third one. So the other thing we're trying to do is fill in some gaps with the produced waters database, which is a big important part of our project. And then one of the main things that we're working on right now that I find the most exciting is that I mentioned there are all kinds of people looking at pulling commodities out of brines. So I've already talked about lithium a lot. I mentioned rare earths, even though I'm a bit skeptical because they are so low concentration compared to other things. And they're frankly kind of difficult to analyze. And then the other main thing people have been trying to use for brines is for carbon storage. And this is the other big project I've been working on for years since I got to the USGS. But as I showed earlier, these are very high concentration of calcium and magnesium, which can be used to basically mineralize CO2 and form carbonates. And we have different partners that have, developed techniques to basically pull. Oh, I should turn off my Teams. I realize you guys can all see all that. Hopefully that won't pop up again. And so basically you can mineralize some of the cations in the brine and form things like cements. And so that's what some of our partners are working on. And the questions that we really have with that are, okay, people have looked at this and said, hey, it's high calcium and magnesium, and let's mix up some kind of sample and see what happens. And now they're at the stage of saying, okay, we need to use real world samples. There are lots of other things in these waters beyond just the inorganic salts that could cause all kinds of issues for their treatment. Not only that, and this is, I mentioned my colleague Bonnie McDevitt, and is working on NORM. One of the big questions is basically, okay, we know a lot of this water is screaming hot for radium. Where's that going to go? Is it going to, depending on what sort of techniques being used, is it going to, is it going to form? Well, the biggest thing would be if it formed in the carbonate, right? And then you're making radioactive cement, which I don't think anybody would want. Or is it being, is it on any sort of filter or membrane or any of the instrumentation that's being used? Is it precipitating out earlier, potentially as a sulfate? And so, what we're doing is we're working with a number of outside partners, sending our samples so that they can then run them. And then they're sending, solids and liquids back at all the different stages. And then we're characterizing those. And then Bonnie specifically is characterizing them for NORM. And so I think that's a pretty interesting and exciting direction, no matter what commodity anyone's looking at. I think it's really important to understand the full chemistry and potentially use a range of real world samples, because they do vary quite a bit. And looks like something froze. Here we go. So I just mentioned we did some sampling in southern Arkansas in late August, and that's my colleague Kathy here, and that is a nice man named Terry, an operator, who collected some of these high H2S samples for us at the wellhead, and I'm surprised he's still alive after that. He's sitting in a plume of gas. Okay. When I tried this beforehand, the video wasn't working, but one thing, so the very last part, and this is just a couple of slides here, are some of these obstacles. Okay, so if we're all very excited about certain commodities, there are just a couple of things that I think are important to think about. And and this is beyond kind of just, environmental impacts and organics and all of these things that could potentially be in the water that we would have to look for. The two main things are going to be high H2S and radium. So I mentioned we were out there sampling a number of these high lithium wells, particularly in the Smackover, have extremely high hydrogen sulfide concentrations, well beyond levels that can kill you. And so we had to, and some of this had been done before in other ways, obviously for years, like back when these were originally sampled in the 70s and 80s, but we did a nitrogen sparge in the field to basically push out all of the H2S before we could actually analyze the samples. And so, hold on a second. It seemed to be moving forward. So there was a nice video here showing that whole process. But so this is us out in the field. This is Colin Doolin here, and we're basically pushing out the H2S, and we're being monitored for H2S. I don't know if you can see, we have like multiple monitors on us, and then we have our industrial hygienist who came out with us, who's basically holding a little wand between that and my face to make sure there's nothing. There's no H2S coming toward me. So just in the sense that, like, in southern Arkansas for the Smackover, they have a whole setup for this. Like, because bromide was their focus and the bromide wells had high H2S and it was definitely economic when they built this stuff, they have a whole system in place. So it and I'm saying this in the sense of, it's not necessarily the easiest thing to say, okay, like we can retrofit whatever sort of well. This should definitely be considered when you're thinking about costs of potentially pulling out high lithium, because you often have high H2S there. Oh, and I loved this. This was posted at one of the places where we sampled, where it was basically allowable facial hair. If you're working in one of these settings, I'm assuming because you have to be able to hold a respirator, but you are not allowed a little wide mustache or any sort of Fu Manchu, but you can have a very narrow mustache if that suits you. Okay, the other thing is norm. Okay, and so I showed this slide earlier. I just want to highlight on the far right again that we basically know that not all, but some of these reservoirs do have high concentrations of radium, like some of the ones that are high lithium, and so there, it's not an impossible thing, right? So there are ways to pre-treat the fluids. If you basically precipitate, if you add sulfate, you basically precipitate out, like almost all the radium will precipitate out as the radiobarite, but then you have a radioactive solid that you have to deal with. So there are ways to think about this. Do we avoid wells that are high radium? That would preclude pretty much the Marcellus and the Utica, right? Because they are both quite high. Or are there ways to actually pre-treat, forming barite, and then you can pull the lithium out after that? Or is the lithium, lithium or other commodity recovery process going to pull out, whatever the commodity is without having to, without basically precipitating radium somewhere, which means then it could be re-injected and disposed of like all the other produced water. So these are the things that our team is looking at right now, is really understanding what's happening to things like radium during the treatment process for all different sorts of recovery processes. So, because I'm on time here. So just to say a couple things and wrap up. If we're thinking about water availability, so if we want to actually reuse the water, we can think of all these things as commodities, right? So the commodity is either something like lithium, or the cations, or the water itself is the commodity, right? So any sort of commodity assessment or water availability assessment, basically we've come up with a way to feed it into any of these sort of models. There are a lot of assumptions that go into it. The concentrate, basically averaging concentrations, but there are ways to kind of tweak this thing depending on where we want to use it. And so, we can do this not just for the water, as I mentioned, but any sort of commodity or any sort of environmental variable that we want to look at. All this is going to be constrained by what sort of data we have. And so, and then just to focus on lithium for a second, it is present in potentially economic concentrations, both in conventional and continuous reservoirs across multiple basins. And if we really want to think about the two main, potential impacts that would affect things like both the costs and they're going to be more costly because they are potentially hazardous. Two things that tend to be associated with some of these reservoirs are going to be H2S and radium. And I believe that's all I have. Finished a couple minutes early. And I will stop sharing my screen so I can see and talk to people. I can still share my screen. I'll just leave it like this.
Thank you, Doctor, for the fascinating talk. There was so much of detail about the elements which we can extract in this wastewater. I don't see any questions in the chat box. People can unmute and ask questions or write it in the chat box.
Hi, Madalyn. This is Bridget. Great presentation. Really appreciate your comprehensive approach. In one of your maps, you seem to show high levels of lithium in the Permian. They were the counties were sort of colored purple. I was interested in that. And then also, you mentioned that a lot of these high concentrations may be in conventional wells. Are those still active wells, do you think, or are some of them decommissioned? Or, that's one of the things that we've been looking at. So
Yeah,
those questions, thanks.
Okay, so first your question about, so this was what the national lithium commodity map maybe?
Yeah.
Okay, so this is interesting because, and this is one of the kind of, I don't know if you call it like pitfalls of this kind of analysis. But so this is the mass of lithium. So we're basically taking the mass of water and then averaging, putting the average lithium on it. And so the Permian is purple just because there's so much water coming out. So, there are ways of like normalizing, to kind of do this in a different way. But this particular analysis was just saying, okay, like how much lithium has actually come out of the ground that we're not taking advantage of. And so it is not particularly concentrated there. And I could show you, I think here.
Yeah, because I think the Marcellus doesn't produce hardly any water. And so then that reflects higher concentrations there, yeah.
Yeah. So I don't know if I can kind of zoom in on this a bit more. There are a couple of like anomalously high-ish spots in the Permian, and some of these things, these are old data, and we did do somewhat of a check to say like, there were certain things that we knocked out, like clearly this is an order, a unit issue. I'll have to double check on that particular point, but yeah, it tends to be fairly low in the Permian for the most part. And it's, in many cases not as, well, actually, I won't say that. I was gonna say it's not as saline, but that's only certain reservoirs. There are very saline reservoirs there. And then honestly, like some of this stuff, I am definitely not sure about. These are older reservoirs. Figure I made that didn't quite make it in here just because it was kind of redundant, didn't have space. I was kind of looking at it was basically this plot, but only the reservoirs that really have a lot of data, right? And so that's going to be kind of the Gulf and the Arkla, and then the Michigan and the Appalachian Basin and the Williston. And so there are places where it is quite high. But yes, so to answer your question, it's not particularly high in the Permian. There's just a lot of water, so that's why it looks that way coming out of
right.
It. Yeah. Your second question, what was your second question?
The conventional wells, are they still active? You think, are they decommissioned, or are they in the IHS database? Bob Reed is probably on this call, but he would probably know better. So I've heard JP say, that a lot of the wells where they see high lithium, maybe they're inactive wells, no longer active.
So that is definitely true. For anything showing up in these maps, I only have data if there was production, in that time frame up to 2020, at least the ones I'm showing you. So yeah, I think many of the high lithium wells are probably inactive. Like the highest ones, right? They're in some of these conventional reservoirs. Not all of them. So for example, some of the stuff we sampled in the Appalachians, like some of the Clinton wells in Ohio, they're not super high, but depending on what cut, I used to kind of have this 100 ppm or milligrams per liter cutoff in my mind, and it's not like exact, but like approximately, and it's kind of getting lower now. One of the interesting things with the Marcellus and the Utica, like it's fair, like they're both elevated and they're consistently elevated. A lot of the conventional reservoirs can be high in regions and low in others. And I have some thoughts about this, but I need to wasn't quite presentation ready. And so, but I'm happy to chat. it's a,
Right.
so yeah, I think that a number of those wells are probably no longer producing. Some of them
Right.
are.
Well, thanks, Madalyn, for a great presentation. Looking forward to interacting with you on this DOE NEWTS project.
Yeah, absolutely.
I would have another question for the lithium mining activities, which is slightly outside from your talk, but do you have any information of salt brine mining activities to extract lithium in the US? The Permian has a lot of salt deposit underground, and I'm wondering whether you have heard about anything in that direction, like it's happening in South America.
Yeah, I definitely have heard things, and I'm not an expert in this, but you know, people have been talking about the Salton Sea, which is a very fun place to go. I haven't been there in a long time. And then there are, I don't remember the name of it, but you know, at this meeting I was at a couple of weeks ago, there was somewhere out west where they were like basically, you know, pulling up geothermal brines and evaporating at the surface. So, you know, there's the mineral resources, there's the like geothermal brine resources. And so both of those are going to be more, usually like more concentrated. But as I mentioned, I think that it's still really high, you know, in these, we haven't done that analysis of like comparing the economics between all these, and that's something that we're thinking about. But like, I think it's reasonable to assume that given all this existing infrastructure and the ability to kind of just like get started with it, I would imagine it's comparable because it still is really elevated in these. I wouldn't say that about rare earths. People call me about rare earths all the time, and you know, and other things, but lithium, yes.
Scott, would you like to go next?
Sure. Hey, Madalyn, thanks for your talk today. I might have missed it, but have you done any looking at kind of the scale of lithium that will be needed if we continue with mandating EVs in various states and even federally to go to that scale of lithium-ion battery production? How much of what you're showing would be needed to satisfy that lithium if we didn't want to be dependent on China for importing, for example? Is it enough? Is it plenty? You know, any kind of proportional feel for that from what you're showing just from brines?
Yeah, so I have seen that, and I don't have the numbers offhand, but it's, you know, the expectation is that it's like increasing exponentially, the demand for lithium. And so right now we don't produce a lot of it here at all. And so it's not that it's rare, right? It's just so this is why a lot of people are looking into other potential sources of it, but it's not currently being mined in large quantities. But yes, I don't have those exact numbers offhand, but I could probably, you know, I'm thinking of a couple of papers I could point you in the direction.
I'd love to see that, because I know, like for hard rock, for example, the Maine has discovered recently a pretty significant lithium deposit in pegmatite there.
Mm-hmm.
But their legislature doesn't really allow mining, but they're mandating EVs. And so, you know, the irony of all this is very rich. And it kind of comes right back to the states that have always produced everything in oil fields, yet just some ironies that are going on. And so I wanted to get a feel for scale. You know, how much would it really take? What would the processes look like? Could we meet the battery demand? And the batteries wear out, so you got to meet it for a long time. You know, It's not like you meet it once and make some batteries and we're all good. You have to make them over and over and over again. So just curious at that kind of scaling.
Yeah. So those questions about demand, like people have definitely looked at that, right? And so the nice thing about this kind of model that we put together is that we can address those specific questions, right? So, or at least estimate them to say, okay, we know that the demand is here. How, like what's the mass of lithium we could probably get out of the Smackover over, in a 10-year time span, assuming production rates similar to the last 10 years or something. And how does that compare to that number? So this is how, and if that's, I mean, I don't know if you're curious because you're working on something like that, or if you're just curious, but like, I'd be happy to chat with you, like these are the kinds of things that we can calculate using this kind of model.
Yeah, that'd be great. Thanks. And thanks for being here today. Appreciate it.
We still have few minutes if anybody would like to unmute and ask the question.
Hi, thanks for your nice talk. I'm just curious, I mean, in the formation water, where the radium is sourced from? Because I see in some reservoirs, I mean, the radium concentration is high, some maybe it's not that high. Yeah.
So the radium is usually from shale reservoirs or reservoirs with a high clay content or anything that had high uranium at some point. Well, not at some point. Anything that at some point, I mean, like it could have moved from a reservoir that had high uranium. So basically during the decay chain, the first really soluble element in water is radium. So if you're starting from either uranium, if you have either high uranium and thorium, and that tends to be high particularly in shales and some carbonates, it's going to, it'll start to decay over a geologic time. And once it decays to radium, it'll go into solution in the water. And so that's why the water tends to be high radium and not like some of the other elements in the decay chain.
Okay, thank you.
But so it doesn't mean it's only from shales. If there was like a, just like if there was a source rock, right, and then the fluids moved from there or it interacted with them, it can still be high radium. And there's a lot of radium in conventional as well.
Madalyn, are you guys going to be doing a lot more sampling in the future? Because this seems to be one of the critical issues is, limited recent up-to-date sampling, and seems difficult to get permission to do the sampling and stuff like that. So I'm just wondering if your plans are to do a lot of sampling in the future.
Yeah, so sampling is always a main component of our project, and as you mentioned, it can be hard to get permission. There's no law that says an oil and gas company has to let us sample their wells. I think except in California there was that law passed, which is why there's a lot of data coming out of there. And so the short answer is yes, we are definitely targeting some of these regions, and I mentioned we were just down in the Smackover. And I remember at first I was like, okay, I'll come help out with that, but I'm sure everyone's looking at the Smackover, and I didn't want to necessarily jump into that with the whole world, trying to get lithium out of the Smackover. But we ended up getting some really cool stuff, and I think have some really exciting interpretations that'll come out of that. So, but yeah, we are actively targeting some of these regions, but that's like some of the hardest thing. It's basically one of the hardest things is convincing people, and that's why I go to these operators conferences a lot to talk about this and try to make those connections.
Well, that's great, and I know that's pound of flesh, so really appreciate all your efforts in that area, because it's really the rate limiting step sometimes to understand the processes and stuff. So thanks for doing that.
Frankly, it's usually easier, I think. I mean, I've been here for a while now, but because we're the federal government, there are a lot of people that don't want us coming in there, right? And so sometimes it is easier to partner with, academics or local government and things like that. And so that, that's what we did for this other project. So I'm definitely, we have the know-how and the facilities, as do you guys, of course. But I'm always happy to talk with any of you about some other regions. But
super, thanks.
Madalyn, just out of curiosity, have you ever considered approaching the disposal well industry rather than the operators? I realize a well is more specific, unless it's commingled.
Yeah.
It's coming from one specific location, which is helpful, but a disposal site might have an interesting combination of water, and I'm not sure if that'd be easier.
It would be easier. And I a couple of years ago, I almost was able to do that, and just for that reason, right? Because I mean, a lot of the work that we've done in this project for a long time has been sort of trying to understand the origin of the brines, right? And we've always looked at, impact and everything like that, but it's sort of a shift in how we think of it as like, okay, if we're really just looking about commodity recovery and reuse and treatment, it only really matters what's coming out of the ground. And so we can kind of avoid having to get these like super precise concentrations of what's in the Utica, making sure we have a well that's been in production so we're not getting frac fluid in there. And so I really was trying to find some companies I could work with where where they'd be willing to like, tell me at least what county or what well, what formation it's coming from. And then we could kind of stand in one place with a bucket, not exactly, and get all these samples and be able to map everything out. That fell through a while back. Once it went to like legal stuff, we had like one really good option in the Appalachians. I haven't thought about it in a while. I did meet with some people who are doing that, and I'm trying to follow up with that. But I'm definitely open to it if you do have any contacts or people that might be willing to do a kind of commodity study by looking at kind of these compiled.
Someone who lives in Texas, you're gonna have the same problem with the federal government walking into a private disposal company. But it would be challenging probably to get that across. But at the same time, I just love the concept that you're getting, and the closest disposal that I can think of that I've been associated with has wells coming from 2, 3, 4 counties. So you get a very interesting mix of water that's all flowing into one commercial deposit. It would obviously be hard to map where it's coming from was what, and so relating lithium to a given formation would be impossible, but the total lithium or whatever element production in a given vicinity would be quite intriguing if you can make it happen.
And it's really interesting too, because when I was talking to a bunch of the operators, I mean, people are paying to dispose of their water, and I keep thinking like, these operating companies are the ones that like not only are they being paid to take it, but they're the ones that have all the stuff, right, and could then process it and make money off it. So I would imagine that if this becomes a thing, there's going to be like a shift in how these things are dealt with, just because.
Have you reached out to
why
Oxy
would
by
you
any
give
chance?
it away? I'm sorry?
Have you reached out to Oxy, Occidental, by any chance?
I have not.
They have a lot of alternative ventures. They've got a lot of investments. I'm not related to them in any way, but they're one that has a ton of water in the Permian. They basically handle their own. They recycle some. I'm not sure what the total number is. If it's published, I haven't seen it. But they might be somebody that would be really interesting to reach out to.
It's interesting because I do have connections to Oxy, but they're mostly, I mean, it was like the California side of things, which doesn't have high, it's fairly fresh over there. But I haven't really looked into like all of their holdings and if it does overlap with any of these, but that would be good to think about. Thank you.
Hi, Madalyn. This is Marcus Durham from DOE's NETL. Just a quick comment on the discussion now. Another type of organization that I would keep in mind are water midstream companies. That sector has just established itself, especially in the Permian, not too long ago, and they process incredible amounts of water. And I know that some of them are very eager to see if there's something of value in this fluid. So NGL, EP, Aris Water, H2O Bridge, those are all companies that I think would be really interested in your work and learning more about what could potentially be done. So I'm happy to make the connection there too. We've established a produced water stakeholder board at DOE just last year. So we've got a lot of those companies on the board, and these are the very questions that they've been coming to us with. So just wanted to throw that into the mix.
Who's actually talking right now? I can't tell.
Oh, it's Marcus Durham from DOE's NETL.
Okay. And then I didn't quite catch the name of those companies, but maybe we can get in touch and I can.
Yeah, sure.
Okay, perfect.
There's a few, and like I said, the water midstream companies I think are another great point of contact for this kind of work.
Okay. Thank you.
Sure.
So it's almost 10. Thank you, Dr. Madalyn. It was very interesting talk, and I definitely learned a lot, though it is not my background. Yeah, and I'm getting requests about the talk recording. So this talk is recorded and will be posted on YouTube in a few weeks. You can get access to the talk. And we will have next week, there will be no seminar on the occasion of Thanksgiving. So I wish you all a very happy Thanksgiving. And we will meet again on next Friday, that is December 2, next, a week after that. That is December 2 with a new speaker. Thank you everyone. Thank you everyone and for joining us, and thank you, Dr. Madalyn, once again.
Thank you so much.